Okay, welcome back again to Number Sense Academy, and today we're going to look at the quadratic formula. The quadratic, can't even spell it properly, quadratic formula. So, the rule of thumb is that not all quadratic equations can be easily factored. In most cases, when we factor, we end up getting integers for our roots and our zeros. Uh, Sometimes those values could actually be rational numbers. They could be decimals, fractions, and so forth, or irrational values. Um, so we need a way to be able to solve for all quadratic equations. So if we have a quadratic equation that looks like y equals ax squared plus bx plus c, then we know that when we set y equals 0, we'll find the values of x that show where the arms of the sketch will cross the x-axis. Typically, we want something in the form of a times x minus r x minus s. So we want to be able to move from this to this easily, and then from here we could extract our roots. Okay, but sometimes it's not that easy. And if you have your equation in vertex form, it is possible to solve to find the roots as well. But sometimes it's just a little bit tricky. But if you don't have your equation in vertex form, you have it just in general standard form, then you want to be able to find your roots. So the quadratic formula is written as such. I say x is equal to negative b plus or minus b squared minus 4ac, and then we're going to divide by 2a. And right off the bat, you could probably figure that a cannot equal 0. If a equals 0, there's two things. First, we're going to be dividing by 2 times 0. So everything up top dividing by 0. And when you divide by 0, it is undefined. You can take 0 and divide by something to get 0, but anything divided by 0 is undefined. The second thing is, if we had the equation y equals ax squared plus bx plus c, and a is equal to 0, then this get wiped out. So we have y equals bx plus c, and this is a linear equation. It is no longer a quadratic equation. So if a is equal to 0, it totally changes this whole setup, and it's no longer a quadratic equation. Now, because we're trying to find the roots, and in some cases there are more than one root, if I write this back out again, I have y equal or x equals negative b plus or minus b squared minus 4ac divided by 2a. There's going to be two values in most cases, or in some cases. And in this case, in order to find those two values, I have the first value, I call it x1. That's going to be negative b plus b squared minus 4ac over 2a. And then the second case is going to be x2, negative b minus b squared minus 4ac over 2a. Okay, so there's a plus case, right? And there's a minus case. Doesn't mean that you're going to end up with a positive and a negative value, because we know how roots work. You could end up with two positive values, you could end up with two negative values, or you could end up with a positive and a negative value. You could end up with one value, and in many cases, there are no roots. There are no roots to the solution, or no solution to the equation. So you can guess how we could end up with positive values here. First of all, if b is negative, I'm going to take the negative of b, right? And negative of a negative number is going to give me a positive, so I'm adding. I have a positive number and I'm adding to it. So if the result of b squared minus 4ac is also positive, I'm going to end up with a positive number, right? And but also we have to pay attention to what's going on underneath, because if a is negative, then you know we could end up with a negative dividing by a negative number, resulting in a negative value. So it's not these plus or minus signs, like it's not these that determine if it's a negative or positive. Now, let's zoom in on this b squared minus 4ac, because that's very important. We can actually make or determine what our solutions will look like just by analyzing b squared minus 4ac. And that has a special name. It's called the discriminant. The discriminant. And that's just b squared minus 4ac. We're not including the radical sign or the square root sign in this case, just looking at the result of what this is. And based on once we calculate b squared minus 4ac, depending what we get for it, we can draw some conclusions about what our solutions will look like. So the first case is if the result of b squared minus 4ac is greater than 0, then what we have is two distinct roots. Okay, so that means that if we sketch the graph, it's going to cross the x-axis at two distinct spots. So it could look like this, right? It's crossing here and here, or it could look like that, or it's crossing here and here, as an example. Okay, so it has two distinct roots. The second scenario, if that result, the discriminant, is equal to 0, then we have one repeating root, which is another way of saying that we just have one root. So the x-axis, or the graph touches the x-axis once. And if you think about it, if it's going to touch the x-axis once, that means the only thing that's touching the x-axis is the vertex. So you could get something that looks like this, where it touches right there, or it could touch at the origin. Okay, so it has one repeating root, and that would be at the vertex. Okay, so let me just write that, at the vertex. The third case is if b squared minus 4ac is less than 0, then we have 0 roots. There are no solutions. We say there is no solution. And this is useful because as you solve the equation, the minute this value is negative, you can pretty much just stop and conclude that there's no roots. Doesn't mean that the equation doesn't exist, because it clearly does. You had an equation to put with values to put into the formula. It's just that there's no roots. And there are many situations like that, and it could look something like this, where you just have a graph that doesn't touch the x-axis. It has all the qualities of a quadratic equation, but it doesn't cross the x-axis or touch it at all. So that's a little too close. So something that looks like this. So the vertex is either above the x-axis or it's below the x-axis. In that case, there's no solution. So those are the three possible scenarios. And like I said, you can check those before you even finish solving the equation. So let's go through a few examples. And as we go through the examples, one of the things that we want to do is look at what's happening with the discriminant before we get to our final answer. We'll kind of just make the assumption, okay, well, since the discriminant is positive, we're expecting two roots, and then we'll just validate it. Or if it's equal to 0, we're expecting one root, and we'll validate. Or if it's less than 0, we're expecting 0 roots, and then we validate. All right, so first example. The first example, we have 6x squared plus 5x minus 6. Right, so how do we figure out what the values are? If you remember, the standard form is y equals ax squared plus bx plus c. So all we're doing is taking the coefficients and replacing them in the equation or the formula. So the formula is x equals negative b plus or minus b squared minus 4ac over 2a. And the values are a is equal to 6, b is equal to 5, and c is equal to negative 6. So that's what we're going to plug into our formula. So we have negative 5 plus or minus, and we have 5, we're going to square that. Then we have 4 times a, which is 6, and c, which is negative 6, and then we're dividing all of that by 2a. And I have no clue why I wrote 2a, because that's completely not proper. It's going to be 2 times 6. And then we're going to simplify as much as we can. So the negative of the negative 5 becomes negative 5. So we'll have plus minus. And then we have 5 squared, which is 25. And we have negative 4 times 6, which is negative 24, times negative 6, which is positive 144. And then we have over 18. So we're going to continue to simplify. And we have 169 over 18. No, not 18, 12. My apologies. 12. All right, so let's pause here and just do a quick assessment of the determinant. So the determinant, b squared minus 4ac, when we solved it, we got 169. This is greater than 0. So we're expecting 2 distinct roots. Okay, so let's see if we get that. So I'm just going to continue this math up here. So we have the square root of 169. So we have negative 5 plus or minus 13 over 12. Okay, so the first root is going to be x1 is equal to negative 5 plus 13 over 12. That is 8 over 12, which is the same as 2 over 3. Okay, so x2, the second root, is going to be negative 5 minus 13 over 12, which is negative 18 over 12. And this is the same as negative 3 over 2. All right, so right off the bat, we have 2 distinct roots, just like we suspected. These are very distinct, they're very different. Okay. Next example, so now we have 5x squared is equal to 7x plus 6. And when you see something like this, no need to panic, just reorganize the equation. So I have 5x squared minus 7x minus 6 equals 0. And then a is going to be 5, b is going to be negative 7, and c is going to be negative 6. And I write out my formula. I always like to write out the formula just so I don't get confused about what to do. And if you make a mistake, you can kind of trace back. So b is negative 7, so I have negative of negative 7. All right, be careful with that. Always pay attention to the signs. And then I have negative 7 squared minus 4 times a, which is 5. And c is negative 6, and that's all over 2a, which is 2 times 5. So what I have is negative 7 is positive 7 plus or minus 49. I have negative 4 times 5, which is 1, which is 20, and then times negative 6 is going to be positive 120. So negative 4 times 5 is negative 20. And negative 20 times positive 6 is going to be 120. So I have 120 underneath. And then I have 2 times 5, which is 10. If I continue, I have 7 plus or minus 169 again over 10. So quickly, we know that 169 is greater than 0. So we're expecting 2 distinct roots. Let's see what happens. So let me just continue over here. So I have negative, nope, it's positive 7. My apologies. So it's 7 plus or minus 13 over 10. So So x1 is going to be 7 plus 13 over 10, which is equal to 20 over 10, and that's equal to 2. And then x2 is going to be 7 minus 13 over 10, which is equal to negative 6 over 10, or negative 3 over 5. Okay, so again, we have two distinct roots, as expected. It's good. All right, next example. So now we have x minus 2 squared equals 4x. Okay, so if you see a shortcut here, it might not work just because of this 4x. If it was just a constant without the x, then you could actually solve for x minus 2 squared equals 4x. I'm just going to do that as an example in case it might benefit you or help you see things differently. So what if I had x minus 2 squared is equal to 4? Okay, so the opposite of squaring is taking the square root. So I would have x minus 2 is equal to the square root of 4. Now x minus 2 is just going to be equal to, the square root of 4 is going to be plus or minus 2. Okay, because negative 2 squared is 4 and 2 squared is 4. So I have to take both. So in case 1, I'm going to have x minus 2 is equal to 2. And this would mean that x is equal to 4. And then in case 2, I have x minus 2 is equal to negative 2, in which case x is equal to 0. So these are the solutions if it was written like this. But the issue is I have a 4x. That's a problem. So the only way I could go about this is I need to simplify x minus 2 or expand x minus 2 squared, and then from there I could solve. I'm just going to erase this. You could rewatch the video if you want to use that as a reference. But, so let me just solve this real quick. So this is going to become x squared minus 4x plus 4 is equal to 4x, and this becomes x squared minus 8x plus 4 equals 0. And then from this, I know that a is equal to 1, b is equal to negative 8, and c is equal to 4. So those I'm going to plug into my equation. Again, I'm going to write it out. So x is equal to negative b plus or minus b squared minus 4ac over 2a. So my values are b is negative 8, so I have negative of negative 8 plus or minus negative 8 squared minus 4 times 1 and then times 4 over 2 times 1. Then I'm going to simplify. I get 8 plus 64 minus 16 over 2, which becomes 8 plus or minus 48 over 2. So 48 is greater than 0, so I'm going to get two distinct roots. All right, so let's we're going to actually find the value of the square root of 48. So let's pull that up here. I'm going to have 8 plus or minus square root of 48 is roughly 6.928, and I'm dividing by 2. So the first case, x1 is going to be 8 plus 6.928 divided by 2. And that gives me 7.464. And then the other case is going to be 8 minus 6.928 over 2. And you end up with 0.536. So again, we have two roots that are different. All right, last one. So now we have 5 times x minus 1 squared is equal to -4. Okay, so just like we did with the previous example, let's see how far we could get just by simplifying or just solving without using the quadratic formula. So if I have 5 times x minus 1 squared is equal to -4, if I divide both sides by -5, I end up with x minus 1 squared is equal to -4/5. And if I take the square root, I end up with x minus 1 is equal to the square root of -4/5. -4/5 is less than 0, so you cannot take the square root. So this is a complex, I should have mentioned this before, this is called a complex number, and you cannot take the square root. So that won't work. So let's just erase this and see how far we get using the quadratic formula. But before we get there, we have to expand all this. So let's expand. So I have 5. X minus 1 squared is going to work out to x squared minus 2x plus 1 is equal to -4. So now I have to distribute the 5, so I end up with 5x squared minus 10x plus 5 equals -4. I'm going to bring the -4 over, so I end up with 5x squared minus 10x. Bring the 4 over, so 5 plus 4 is plus 9 equals 0. All right, so A is equal to 5, B is equal to -10, C is equal to 9. So let's plug this in and see where we go. So we have x is equal to -b plus or minus b squared minus 4ac over 2 times a. So b's become negative of -10 plus or minus -10 squared, and then minus 4 times a, which is 5, and then c, which is 9, over 2 times 5. So we end up with 10 plus or minus -10 squared is 100. -4 times 5 is -20 times 9 is 180. So minus 180 over 10. Okay, so I'm going to expand one step further. So 10 plus or minus -80 over 10. So -80 is less than 0. This means there is no solution. So we can't go further, and we won't go further, because this thing is already validated that because this value is less than 0, there are no solutions. Thank you for watching Quadratic Formula, how to use the quadratic formula. Cheers.